Hello, welcome to week one of the Sustainable Energy MOOC. My name is Arno Smets, professor in solar energy at Delft University of Technology, and I will be your lecturer during this first week of this course. This week, we will be taking a look at the basics of energy systems. First, let us take a moment to think about the word itself, energy. What comes to your mind when you think about energy? This seems like a simple question, but when I ask this to my students, they realize the answer is not straightforward. Energy appears in different forms. The energy of motion, kinetic energy, stored energy, potential energy like gravitational energy, mechanical energy, which is both, thermal energy, chemical energy, radiant energy, light, nuclear energy, gravitational energy. To understand and compare the different forms of energy that we see around us, it is important to be able to define and quantify energy. In the upcoming two introduction videos, I will discuss the units of energy, you will be introduced to the energy carriers, and we discuss the conversion of energy. The learning objectives are first to quantify the amount of energy using the different energy units. And the second learning objective is to identify the various energy carriers. And the last one is to understand the basic principles to describe energy conversion from one form of energy into another form of energy. Energy is often described as the ability of a system to do work or cause change. The unit of energy, the joule, is related to mechanical energy. Let's consider this cup of water. This cup of water has a mass of about 100 grams or 0.1 kilogram. Here on planet Earth, this cup experiences a gravitational force which has the mass times the gravity constant of approximately 10 meters per second square. This results in a gravitational force of 1 Newton. Now I lift this cup up by 1 meter. The total energy needed for this is exactly 1 joule by definition, which is 1 meter multiplied by 1 Newton. 1 joule is defined as the amount of energy required to move an object by a distance of 1 meter against a force of 1 Newton. Mathematically, 1 joule is equal to 1 Newton meter of energy. 1 joule of energy is too small to quantify the energy that we encounter in our daily lives. In energy analysis, you would normally encounter higher orders of magnitude, such as the kilojoule, equivalent to 1000 joules, and the megajoule, equivalent to 1,000,000 joules. The scale on the left-hand side of the screen shows the joule in increasing orders of magnitude with steps of thousands. The gigajoules is equal to billion joules, the terajoule is equal to trillion joules, and the petajoule is equal to quadrillion joules, and etajoule is equal to quintillion joules. That is a 1 with 18 zeros. To put all the different orders of magnitudes into a context, we can all relate to ourselves. Therefore, it's not an official unit, but just for fun, I will now define the human unit. This will help us to compare energy at a more personal level. The average person requires about 10.46 megajoules of chemical energy in the form of food every day to stay healthy and function normally. We will now refer to this quantity of energy as 1 human unit. 1 human unit of energy is equal then to a 10.46 megajoules. Now let us look at the daily energy use that we encounter in our everyday lives. A 16-watt lamp requires about 1.4 megajoules of energy if it were kept on for 24 hours a day. With our new system, this equals to 0.13 human units. The total energy consumption of an average person living in Europe is about 411 megajoules a day. This includes the energy used for his transportation, cooking, heating, lighting, and other daily activities. In human units, this is equal to 30.3 human units. This means that the average European person consumes almost 40 times the amount of energy required to sustain oneself. This figure naturally depends on standards of living and is different for each person, of course. The consumption of a small bookshop is in an order of magnitude higher. The average bookshop consumes over 5,400 megajoules per day, or 5.5 gigajoules of energy per day. This is equivalent of 524 human units. Thus, every day the average bookshop uses enough energy for you, if it would be in the form of chemical energy or food, to sustain yourself for almost a year and a half. Moving further up the scale, we come to the next order of magnitude. A regular 500 megawatt coal-fired power plant produces over 43,000 megajoules or 40.32 gigajoules daily. This is enough energy for over 4.1 million people to sustain themselves for a day. The next step on the scale is the consumption level of an entire country. The daily energy consumption of the Netherlands, for instance, a small developed country, is more than 8,000 terajoules or 8 petajoules. A country of around 80 million people, like the Netherlands, consumes enough energy every day to meet the daily food energy requirements of 783 million people. Finally, the daily energy consumption of the entire world is approximated at over 1,200 petajoules or 1.2 exajoules. This is equal to 118 billion human units. To put this into perspective, the entire human population on the Earth in 2026 is about 8.3 billion people. We saw in an earlier slide that the joule, the unit of energy, is defined in relation to mechanical energy. However, energy has several different forms, and the definition of energy might change with each form. Consequently, industry which deal with a particular form of energy use can use a different unit corresponding to that particular definition of energy. Thermal energy is defined by the energy required to raise the temperature of water. The unit of thermal energy is the calorie, which is equal to 4.184 joules. The chemical energy contained in food is much larger than a calorie. The food industry therefore uses higher order magnitude, the kilocalorie. The kilocalorie is also sometimes called calorie, but written with a capital C, like in the US. Electrical energy is measured in kilowatt hours. Each kilowatt hour is equal to 3.6 megajoules. Let's make it personal again. Remember the human unit we just discussed? Each unit is equal to 2,500 kilocalories or 2.9 kilowatt hour, which is the daily food energy required of the average person. From this point on, whenever possible, the kilowatt hour will be used as the unit of energy. The oil and gas industry deals with much larger volumes of energy. 1 ton of oil equivalent, abbreviated as TOE, is the equivalent of 40.87 gigajoules. In our terms, 1 ton of oil has an energy equal to 11,600 kilowatt hours. In addition to these, there are some units that had historical significance and are still used in certain parts of the world. One such unit is the British Thermal Unit, or BTU, which is still used in countries like Canada and the United States. It is used to describe the energy content of fuels and heating system. It was originally defined as the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Power is a term which is often used when talking about the output of machines or processes. Power is defined as the rate at which work is done. It can also be defined as the amount of energy used per unit of time. The unit of power is called the watt, after the Scottish engineer James Watt. 1 watt is the amount of power produced when 1 joule of energy is used in 1 second. Mathematically, 1 watt is expressed as 1 joule per second. In the 18th century, draft horses were used by James Watt, the inventor of the modern steam engine, as a frame of reference to define the power of steam engine. It was an excellent marketing tool to show his steam engine's power relative to that of the state-of-the-art power generators of that day, being horses. The horsepower is a unit which is still used today to express the power of electrical machines and engines, especially in the transportation industry. 1 horsepower is roughly equal to 746 watts. The electrical appliances that we use in our homes usually have a label with a power rating. The amount of energy used by the appliances depends on the time for which it is used. A lamp rated at 40 watt, if used for 8 hours, will use 40 watts multiplied by 8 hours, which is equal to 320 watt hours, or 0.32 kilowatt hours of energy. On your electricity bill, the electrical energy usage is expressed in kilowatt hours. You can easily calculate the energy used by other home appliances by looking at their power rating on the label and multiplying that by the number of hours for which the appliance has been used. This is a fun exercise to do. Can you estimate the amount of energy consumed on an average day in your house by filling up a similar table like this? In the second introduction video, you will be introduced to the energy carriers and we will discuss the concept of energy conversion. See you in the next video.